Let us assume that we want to do VXLAN and we got our traditional classical network, and let's say this is a computer with VLAN 10, but this is of tenant called, let's say, Federal Bank. This pink color, no? The pink color, that's Federal Bank. VLAN 10, VLAN 10, VLAN 10. Now, Federal Bank, they may have 1,000 VLANs or 4,000 VLANs. I'm just drawing only one VLAN, VLAN 10. Now, this blue, let me call it as CBN, Central Bank of Nigeria. They also have got same VLAN number, VLAN 10, VLAN 10, VLAN 10, VLAN 10. Central Bank of Nigeria is in blue in the access layer. This is access layer. Now, you may also have a layer 2 switch here and many VLANs connected to that switch, and you will then have this as a trunk. If you will have this switch, then it should be trunk. Now, let us not focus on that area. No, this is all access, 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 access. Access. You see, we have multi-tenancy. You can have multiple tenants. I told you, for each tenant, you can provide mapping of VLAN from 1 to 4096. Here you got plenty of VNI, VXLAN network identifier, plenty of VNIs, 16 million plus. So Federal Bank's 4,000, how many will consume? Only 4,000. Standard Chartered, sorry, Central Bank of Nigeria, 4,000 VLAN. How much then? 8,000 out of 16 million you have consumed. Likewise, you can consume up to 16 million in one VXLAN fabric. One tenant has got no visibility to other tenant. They're totally isolated. So the VNIs that you are going to allocate for Standard Chartered, sorry, Central Bank of Nigeria, is not going to be given to any other tenant. VLAN may be same, but VNI is what matters in between leaf to leaf communication. It's not your VLAN, it's only VNI. That VNI is going to be unique for all customers. The VLAN may be same, but VLAN is not considered inside this fabric. Packet gets encapsulated here, gets decapsulated here. Encapsulated here, only decapsulated here. Doesn't matter. If VLAN is same, doesn't matter. So VLAN to VNI mapping is done on leaf, and when the traffic comes, encapsulation happens on leaf. and goes to the remote VTAP, remote leaf, gets decapsulated and delivered to the right interface out using the location mapping table. We'll talk about that in today's class. So, did I answer your question, Mr. Girish?
Uh, yes, sir. But again, uh,
Ask
one
your
more
question
thing
again.
is, yeah. So here,
Sorry, your voice is not heard.
yeah, yeah. So
Yeah.
now is it audible?
Yes, yes, I can.
My yeah. One of my doubts
Yes.
is cleared, but another doubt is the federal bank is having 6,000 VLANs, for example. So how will
6,000 wheeler? No, no, no. That's not possible.
so how can they accommodate?
That is not no, in reality that is not not seen anywhere. No, no single organization need that many. No need. Why an organization? It need not to be a bank. It can be anything. Any big network you take. 6,000 VLANs. Why do you need? That is no. That is too much. That's not really need. That 4,000 is uh, plenty for any organization. Now, the fabric accommodating multi-tenancy is what VXLAN guarantees. For one customer, if you are going beyond 4,000, then there is something wrong with our design in Federal Bank. So better reconsider the number of VLANs. One customer needs more than 1,000. So can you really manage,
No, we will not be able to.
Girish? You know, when you say VLAN, you mean one network. So in one single organization, do you really have 1,000 networks? And why you need 6,000 for one organization? No, not practically needed. Maybe when everything goes AI, artificial intelligence, what people keep saying again and again today, then there is chance of what you are saying. For every single piece, if you need an IP address, then all the pen will be identified with one IP address. All pen in my table. All cell phones, no, not all cell phones. All the keys in my house needs an ID. Oh, no, I don't want to say too much, you know. All the water bottles need an IP address. Then all bottles in one VLAN. All pen in one VLAN. All the chairs in another VLAN. Then there are chances for an organization to have 6,000 VLANs. But human being will not dare to take such approach because we don't want chair to be identified in a network, pen to be identified in a network. So, is your second question valid?
No, it's not a
No.
valid.
All right. So the first question was still the number of VLAN is only 4,096. Though VXLAN supports 16 million, you're going to map the VLAN to VNI, then you are only able to use 4,096 VLANs. What change it makes? VXLAN doesn't make any change. That's what your question. My answer is you are seeing from the end user perspective. VXLAN is a cloud service. VXLAN is a big fabric in which multiple end users, multiple tenants come and use that underlay physical infrastructure. In that case, VXLAN is important. Here, we are going to again get into the very basics of VXLAN EVPN today.
So this is more of a perspective on service provider and in the data center issue.
Yeah, service
Okay.
provider. The service provider and data center. That's right. Now, data center is also a service provider. Yeah, any service provider who provides service to multiple
Okay.
tenants. Okay. Now, this VXLAN needs a mechanism to know whereabout, to know which end hosts are connected behind which VTAP. You see, this end host of Federal Bank is connected behind this VTAP. Let me call leaf 1. And this information is needed on all other switches. So there is a need to know the location and the identity. Those who learn VXLAN, ACI is a piece of SD1 is a piece of cake. Locale, here location.
Yes, sir.
The word local will come there. Okay. Now, what is this identity? Identity is nothing but this particular federal bank's IP address, let's say 10.0.0.1, and the MAC address, let's say FFFFF MAC address. And this is behind what? Behind the VTAP, let's say the VTAP address is 1.1.1.1. Yeah. So the information like which location is responsible or which leaf is responsible for encapsulation and decapsulation of traffic for this end host is what VXLAN need. VXLAN needs this info. VXLAN want to know who is going to encapsulate and decapsulate the traffic that is coming from 10.0.0.1 FFFFFFFFF MAC address. Usually MAC address will not have F. If it is F, then it is going to be a broadcast. Just like take it a different number. MAC address is 1A, 2B, 3C. So this is the MAC address. So identity is 10.0.0.1, comma 1A, 2B, C3. MAC. Location is 1.1.1. What is the location? A VTAP address. Who is a VTAP? The one who
Sir, in this
encapsulates
case, actually,
This
then
VTAP
traffic and
address
send.
is the MAC address of the switch, right? The leaf.
No, this MAC address is the MAC address of the host. This IP address is the MAC address, the IP address of the host. That is what identity here. Location is the VTAP. This information is what called as location identity mapping database, which is needed on the other switches. The other switches need to know which IP address I should go in order to go to this host. Now, if you check the routing table 1.1.1.1, your routing table is going to show you two paths with the help of OSPF. And then you go and check your adjacency table, learn the MAC address of this guy, forward the packet here, learn the MAC address of this guy, forward to this guy, and then again decapsulate, encapsulate the MAC. That's a local story. You're getting mixed with those both stories. A question. Ask question.
So, so the CBN also, VLAN 10, will have the same IP address. So, in that case, we will be distinguishing uniquely using the VNI, right? Same MAC address, IP address.
We'll talk about that. Yeah, VNI is going to come into picture. Correct. That I have not brought into picture right now.
Okay.
You're right. Yep. We saw that there is a need for location identity mapping database. What does the database contain? It contains identity of the end host using its IP address and MAC address and etc. When we say location, what does it has? It has got identities of VTAP, which is responsible for encapsulating along with VNIs, as our Girish was telling, along with VNI, encapsulating and decapsulating the traffic that passed through and come through the tunnel. Whose traffic? End host traffic. Okay. So to know this, in order to build this database, what database? Location identity mapping database. Location identity mapping database. To build this table, all the switches need to build this table. They need to know which end host is connected behind which location, which identity is seen behind which location. They all need to know that. To know that, VXLAN flooding and learning can be used. Flooding and learning can be used. But the problem with this is scalability. In order to learn the end host, which is behind those VTAPs, the flooding is needed. Flooding the traffic in order to learn always will not help for a large scale environment. That's why the use of MPBGP comes into picture. MPBGP, Ethernet VPN will solve this scalability issue. How? That flooding and learning is minimized. Minimum flooding and learning. How? Whenever an IP address and MAC address is identified on a leaf, immediately BGP is going to advertise it to the other peers. So the layer 2 EVPN or BGP layer 2 VPN EVPN address family, this allows the host MAC address, IP address, VRF, VTAP informations to carry to MPBGP, carry over MPBGP, meaning what? It carries to all the BGP peers, right? So it is carried to all the BGP peers, MPBGP peers. There is no need for flooding here. But there is flooding involved. whenever there is a bump traffic, which we'll talk a bit later. So minimizing the flooding is like this. The information like MAC address, IP address, the VRF to which the end host belong to, the VTAPs, all these informations are carried in MPBGP. Yeah, and the reachability between the VTAPs are taken care by the local routing protocol. The endpoints are nothing but VPN tunnel endpoints are nothing but BGP EVPN peers between which this end host informations are distributed. So underlay provides how to reach VTAPs. VTAPs IP. Overlay, now how this provides, OSPF or ISIs. Overlay behind the VTP, the end host MAC address IP and the VTAP that is responsible for that is being distributed over the overlay. Yeah, so we should have this clear picture. So when a MAC address is learned, when a host is learned, when I say host, it means both MAC address and IP address. When this host is learned, BGP EVPN is going to distribute, and this information goes to the other EVPN peers, other EVPN speakers, which are in the same underlay, inside this fabric. So as long as this is available, the message will not time out. So there is no need for flooding and learning. There is no need of time age out also. You know about BGP. When something goes wrong, it sends a message. It informs others. Routing protocol, all routing protocol, they send the info. We call it as what? BGP notification packets. So there is no need for age out. There is no need for flooding and learning. Age out of what? Age out of location identity mapping database. There is no need of age out. And now coming to the bump traffic. Broadcast, unknown unicast, and multicast traffic. If the source host, let's say this federal bank, wants to send a particular traffic to multiple destinations, there are two methods in which you can distribute this. One is you can rely on BGP. Another one is you can have statically mapping to multiple destinations. You can use multicast. Okay, let me explain you in a detailed way. For bump traffic, you can use multicast, or statically you map saying if bump traffic is seen, to whom all it needs to be delivered, to which BGP, to what all, to what all, to which, I think which is plural, to which BGP peers it needs to be sent. You can manually, you can statically provide the info. We call it as ingress replication. We have seen this in early VXLAN class, not in this batch, some other batch. Ko and Girish have seen this ingress replication multicast. But this time it will be more clear, I know. You feel more clear with the concepts. Okay, so you can statically say, you can manually say that if you encounter any bump traffic, you deliver those packets to so and so tunnel endpoints, so and so VTAPs. That is ingress replication. Or you just give one multicast address on all the leaves. So if any leaf have got any bump traffic, it will send to that multicast address and it will be delivered to that IGMP group, that multicast group. Or you can have MPBGP EVPN. MPBGP, to solve this problem, it has got different route types. I'm going to say something very important now. MPBGP EVPN has different route types. I don't know about the other implementation. In Cisco's implementation, we use route type 3, 2, like LSA type in OSPF, no? We have types 2, 3, and 5 used by Cisco. What is type 2? Route type 2. See, when you capture this VXLAN packet, you will see these things. In Wireshark, you can see route type 2. This is route type. Like we used to see, hello packets or LSA type 1 packet, LSA type 2 packet when you capture Wireshark. Likewise, you can also see these types by capturing when you have VXLAN. When we do the lab, when we use that Wireshark to capture the traffic, you can see these things. Route type 2 carries MAC address or IP address, which are advertised by one BGP to other peers. Map IP advertisement routes. So for all the endpoint, end host, the reachability information like MAC address, IP address are carried in a route type called 2. We are talking about MPBGP. If you are not going to go with the ingress replication or multicasting, if you leave it to MPBGP to do that, then there should be some special type to carry the bump traffic. What is that? Type 2, sorry, type 3. Route type 3 of MPBGP, it distributes on behalf of ingress replication. So it delivers to the multicast group the distribution list. So in route 3, what I want to say is it helps to create a distribution list. for increased replication. So we use this BGP to use that increased replication, that static configuration that you have put, the IP address, and we tell BGP use that increase means distribution list and deliver to them. So increased replication. So it's not three types. Sorry, I think I missed here. You use multicasting or increased replication.
Okay,
Increased
sir.
replication uses BGP
So type
and
2
it
will
uses
be,
type 3. So all the BGP peers, type 2 is normal route IP mapping information that it advertises. Type 3 advertises the distribution list, who are all in this group. And type 5 is going to simply advertise the IP route info, means layer 3. Route type 3, sorry, type 5 is simply IP route information, provides the IP prefix and the prefix length. So this is what advertised in EVPN as type 5, IP address and the subnet mask, prefix length. Type 3 advertises the distribution list to whom the bump traffic will be distributed. Type 2 advertises those end host information. That's all you need. So like you have different LSA types in OSPF, here also you got different route types. Very easy for us to match. If you want to match the distribution list, if you want to check the distribution list, then you need to filter type 3 advertisements. Then you can easily troubleshoot. If you filter those type 2 in Wireshark route type 2 of MPBGP, then you will know what all MAC address and IP address of the end host is getting advertised. So you can easily troubleshoot which one is missing, and it will be easy.
sir,
So
route
it's
type
not
3
going
and
like
route
one
type
single
5,
update. You got
are we not
different
sending the MAC address?
types: route type 2, route type 3, and route type 5. Question.
Okay, so for them, then for the vMotion, you
No,
told
they
right we
don't.
need the layer 2 adjustment.
They don't.
Okay.
That is what type 2 is going, no? See, for VXLAN communication, all these three informations are important, but who carries which one is what shown here. In BGP update, when you capture the packet, you will know what is type 2. Type 2, if you filter all the type 2 packets, then you will see those end host information only. End host information and the VTAP, which is responsible for encryption and encapsulation and decryption. When you capture those, when you filter those type 2, type 3 packets in Wireshark of EVPN, then you cannot expect that MAC address, IP address, VTAP mapping. You should only expect the distribution list to whom the EVPN is going to distribute. And in route type 2, you can expect only IP address and the subnet mask, nothing else.
Okay, sir.
When we do lab, we'll capture and see for better insight on this. Okay. So next is the route distinguisher in BGP, EVPN, and route target in BGP EVPN. We learned that in the very first class as well as in the second class, multi-tenant. Multi-tenant is one of the specialty of VXLAN, which is possible because of VRF. And VRF makes this possible by using route distinguisher and route target. So all the tunnel traffic, that's the important angle in which you need to see. All the tunnel traffic needs a separate control plane, meaning all the traffic that is coming from the access layer to the leaf, they only should use what? The tunnel. Is tunnel for insiders? No. So we need to make sure that there is a separate control plane for the traffic coming from access layer, so that that control plane can be connected to the tunnel. See, there is a physical fabric. For that, there is a control plane. There is a routing table. We cannot mix that routing table with the routing table with the route information with the endorsed information. We cannot mix that both. We want to keep these endorsed information separate on leaf so that we can easily map to the tunnel, to the VXLAN tunnel. So we need a separate control plane. And that separate control plane is what called as virtual router. The virtual router is configured using VRF. So when you configure VRF, for each customer one VRF, you can have overlapping IP address, VLANs, etc. Why? Because the routing domains are different. Each VRF have got separate control plane. What does it mean? They have separate routing domain. So they're isolated routing domains. So VRF is important. Only those traffics that enters into VRF domain will be passed through the tunnel, VXLAN tunnel. Fine. But when you have multiple tenant, like Federal Bank, Central Bank of Nigeria, when you have something like, different tenants, there is a need for a route distinguisher to differentiate the routes that is going to be stored in this BGP table. Route distinguisher is needed. With the route distinguisher, I can say these MAC address and IP address that I'm learning is of Federal Bank. This MAC address and IP address that I'm learning is of Central Bank of Nigeria. So there is need for a route distinguisher. For CBN, I have got a separate control plane. For FB, I got separate control plane, separate virtual router, isolated routing domains. Now this route distinguisher is of 64-bit. RD is of 8 bytes, which is 64-bit. All right. And And this route distinguisher, this what I'm going to say may be a confusing thing for you, but that is the truth, but not that important. Just to know, I'm telling, I have not said this in service provider classes. This route distinguisher is 64-bit and it has got 3 field.
Yes.
Usually what you do, route distinguisher 1:1. That's what we used to say. But this route distinguisher has got 3 fields. One is type. Now we have 3 types: type 0, type 1, type 2. This is one field. What type is one field? Another field is in type 0, the second field will be 2 bytes of autonomous system number. This is the second field. Out of 8 byte, 2 byte of autonomous system number. And then 4 byte of some value, any number you can type. Type 1 is 4 byte of IP address, which is 32-bit, 4 byte, and any number, 2 byte of value. And in type 2, you can use 4 byte of AS number and 2 byte of value. So it depends what you put. If you put AS number, then you mean type 2 route distinguisher. If you put just a 2 byte of AS number and some number, then it's type 0. If you put IP address in the front, then it immediately understands that you are talking about type. Again, this is not that important. Another important thing that I want to tell you is these are dynamically assigned in Nexus, in ASR. Whenever you do EVPN, these things are dynamically assigned. Route distinguisher is auto assigned. You can also manually assign. If you are going for manual, then you can use any one of this type. So this route distinguisher for each VRF that we give or automatically given is added to the IP address so that the IP address can be unique. We all know that 2 customers can have same IP address because they are of 2 different routing domain. Even though they belong to one single physical fabric, they don't belong to one routing domain because VRF divides them, isolates them. So let's say I have a VRF called Federal Bank, another VRF called Central Bank of Nigeria. I'll give route distinguisher, let's say 1:1, and here I give route distinguisher 2:2. Now in Federal Bank, there is a host 10.1.1.1/32. or let's say the entire subnet. There's a subnet. In CBN also I have 10.1.1.0/24. So how it looks in the control plane. When you check the BGP EVPN control plane, this will be seen like this: 1:1 10.1.1.0/24. And this is seen as 2:2 10.1.0/24. See, it's uniqueness. This is totally unique. They're not same. Only when you don't have RD attached, it looks like same. But always RD is attached in the beginning in order to provide that uniqueness among the root. So there is no problem if two customer having same IP address. Route distinguisher takes care of it. Likewise, we have route target, which is extended BGP community to identify the routes so that when you export, that can be imported by the right target. That's why it is called as route target. It's BGP extended community value. So all the routes coming from Federal Bank will have one export value. So the remote office of Federal Bank can use it as an import value. This RT is also 64 byte. Sorry, 64 bit, 8 byte. (64-bit). Yeah. So where is this RD? RT. See, when you manually configure RT, you can use this format if you want. Okay. Again, it's not mandatory. You can use format like the autonomous system number of the customer, say 10 colon, the VNI number for that customer, Federal Bank, who is from autonomous system 10 BGP. You might have given VNI 1010 RT format. You can use this type of format. Like I said, for route distinguisher, you put IP address of the customer 10.0.0 1 or 0 colon some number, some value that I'm meaning type 2, sorry, type 1 IP address and some value. Or you can simply keep it simple like 1 colon 1. Your wish. But good news is here it is auto configured, automatically driven.
So VNA is also 32-bit?
In Cisco's VXLAN configuration, you will see those things are automatically configured.
So, yeah, I found that. So then in the RT, you told the first
VNA is
10
24.
column,
What happened?
1010. That 1010 will be.
You see, is this
That
okay? Is this how many bit is the 1? How many bit is this one? 64. I'm not using those bits. I'm just using zeros in front of all, and only the last bit is turned on. You got it? I got 64, okay, but I am not using. Sorry, I got 32, but I am not using all 32. have 0, 0, 0, 0, 0, 0, and 1. That's how you got this 1. Yeah, yeah. Right. So let's quickly have one quick revision. See, what we have is we have an underlying routing. See, the next thing is we are going to do lab. So I'm going to quickly revise for you. We are going to have an IGP underlay routing, like OSPF or something like that. And then we are going to have a multicast underlay, multicasting in the underlay routing. And then we are going to have BGP underlay control plane. We are going to form neighbor, IBGP neighbor. And then we are going to enable MPBGP EVPN so that location identity mapping database can be built. MAC address to VNI number mapping, IP address to layer 3 VNI mapping, all those things happens, and the data plane gets built. Using the data plane, when the traffic enters, the encapsulation is going to happen. It's going to encapsulate with the remote VTAP address and the other routing stuff, right? So these are the things that you're going to expect when you need to expect when you do the configuration. How these things are achieved, is what we are going to. Before we go to that configuration part, let's see how the VXLAN header looks. Now, what do we see here is the outer MAC header. You know what it means. This is the header which keeps changing. This is not the end host MAC address. This is the VXLAN fabric intermediate device MAC address. And this is the layer 3 header of that fabric, the VTAP address, the VTAP source, VTAP destination address. You can also see here the destination host and VTAP address. This is the layer 2 of inside. This is not the end host. This is the fabrics. And then you got UDP header, the VXLAN encapsulation. See the VXLAN carrier. This is the one which carries the traffic. All right. This will also have inside the VNI information. And then, this is not showing the, okay, here it is, original frame. The original frame will have what? They have not mentioned it properly. This will have the original destination MAC address, source MAC address. If you have a trunk port, then you will have .1Q, ether type, the payload, the CRC, etc. This is what you will see in here, right? So the original frame layer 2 information is inside. VTAP, it never changes, which is very important for
everything will no, so when this thing comes out of the
VMware
end VTAP,
for VMware vMotion,
only the original L2 frame will be passed.
When you only this will be revealed when it is decapsulated. This is what you will see if you capture the packet in between leaf and spine. You will see all this. Okay. If you capture on the access port of the leaf, you will see only this. You won't see any of this. You will not see any of this. Right. So let me also try to get a screenshot of Wireshark. If you see here, this one is very clear. This is the VXLAN coming in picture, and they are using some custom port number. I told you for security people use custom port number. The original port number is UDP. See, it's UDP, user datagram protocol. The original port number is 4789. Easy to remember. 789 4789. And this is the original source MAC address, destination MAC address, original host IP address, same subnet. They belong to same subnet. Whereas above UDP, if you see the VTAP address and the MAC address of the hops between leaves. So this may be leaf source, this may be the spine on the top. After going to the spine, again it will change. This MAC address will change. But IP address will never change. This MAC address will change. All right. So this is one sample. We will also get some capture and we will see later. Right. Because I really want to open this VXLAN plus. I want to open this and show you. Okay, let us see some other picture. Now, what do we see here? When you open this VXLAN, you can see it's VNI enabled traffic. And this is the VNI number 58. See, some version of devices allows you to use number from 1 to that 16 million. But some will allow you only after 4096, means 4097 onwards. But most of the device will allow you to start from number 1. So here they are using 58. Don't think that it will conflict with VLAN. No, it will never conflict with
When we
VLAN because this
configure,
is
we can match
on
this
top of UDP.
VNI10
Your VLAN and all
for
will
the
come only
VLAN 10.
here.
Okay. Yeah.
Or if it is a host VLAN, then it will come only here. No, nothing, no problem. Yeah, you can very well do that. If your device don't support number between 1 to 149, then you need to give some 4-digit number above 4096. But most of the device
Yes.
supports. You can say
And the
VLAN 10,
destination port
VNI also 10.
8472,
Nothing
that
wrong.
means it is replacing the 478.
Nothing wrong. It will avoid confusion. Yeah, you saw that, right? Yes.
Okay.
Yes.
Okay.
Yeah, someone has given customized one. The original is 4789. When you configure, there is one easy command to say the port number, so everyone started changing the port number. All right. So what comes next is a wonderful basic VXLAN EVPN layer 2 forwarding lab. All right, that's what we are going to do as next on